Point D, we're 5 milliliters past the equivalence point. So again, mixing the two solutions, doing your dilution shortcut, and then using those numbers as your start of the ice chart. This time, the limiting reactant is the original weak base. All of this is now consumed, which means we're going to have some strong acid left over. So after your ice chart, identify that we have some strong acid, we have some weak acid, and bromide is neutral, so that's not an acid, not a base. This is the first time we've seen a strong acid and a weak acid together in the same solution. Strong acids do not react with weak acids. Acids react with bases. So the first thing to notice is the strong acid will not react with the weak acid. If you look at the numbers, we have a lot more of the weak acid than we do the strong acid. But remember that a weak acid reacts to a very small extent because it has a very small Ka. In other words, the weak acid will make a tiny amount of hydronium compared to the strong acid. So when you have one component left in your solution that's strong and one component that's weak, we're going to ignore the weak acid because that chemical does not make very much hydronium. It's not going to change the pH very much. So we can find the pH by just looking at the strong acid, and all of the strong acid, remember, turns into hydronium. So the pH is just the negative log of 0.0435, which gives us a very acidic 1.36 for our pH. If we had had a strong base and a weak acid, the point on the titration curve when you are past the equivalence, you'll have a strong base and a weak base together in the same solution. Just like in this example, we're going to ignore the contribution of the weak base, and the pH is controlled by the strong base.